In this lesson, we'll enable physics in our game. Why would you want physics simulation? Well, we need things such as gravity, we need collision detection, and for those things you need to simulate physical bodies. The way this works in Phaser is as follows. You enable your physics system on a global level for your game, so that your game has this component ready for you to use, and then you have to enable individual sprites to be represented by a physical body. That's the term used in Phaser. Why are not all sprites automatically simulated as physical elements with gravity and all those fancy things? Well, because you might want to have some sprite that represents, say, the number of lives that you have, or could be a logo or some icon or something like that. So you have to manually say which sprites are simulated by physics. And only those sprites can do collision detection and all those other cool things, like have velocity and have acceleration, and having two things collide with each other, and there will be momentum going from one element to the other, and all those things. So let's initiate our physics system. We'll go to our init method, and we type in this.game.physics.startSystem. And the system we want to start is called the arcade system. We type in phaser.physics.arcade in uppercase. The arcade system simulates everything as rectangles, which is what we want, and it's just very simple to implement, very easy to use, and not too heavy on the resource consumption side of things, which is always important, especially on the mobile phones. We can define gravity on a global level, or we can say that individual elements have a gravity with different values. In this case, we just want to set gravity for the whole game, so that all elements are subjects to it unless we specify otherwise, which we will have to do, otherwise things like the floor will just fall down with gravity. So you access the arcade object and then .gravity, and gravity can be in X or in Y or both, but we only want gravity on Y, and we want to be downwards. So you give it a value. I'm going to give it a value of 1,000. How do you know what value to give it? It's the sort of things that you learn by trial and error. So you put in a number, you'll see that it's falling really slow. Then you put in another number, it'll be too quick. And you'll find a number that suits your game, that you find that it looks good. So, I now have to enable a physical body on my sprites if I want them to respond to gravity and to physics in general. The way to do that is by accessing this arcade object again and using the method enable. And using the method enable, then we pass the sprite as a parameter. So I'm going to do that for the ground, and I'm going to do that for the platform and for my player. So let's put these things in place, this .player, and restart the page. See what we have now. See that now everything is falling with gravity. And if we made gravity slower, you would see that it's just very slow, which might be for some games, or if you're simulating that you're on the moon or something like that. Okay, so I don't want my floor and my platforms to respond to gravity. Therefore, I have to disable gravity on them. After we enable physics on a sprite, we have a body object on that sprite that gives us access to a lot of things. You should do console.log and put in the body so that you can see in the console what the body includes. Also, look at the documentation for the arcade. So the body gives us access to things such as velocity and mass and a lot of other physical stuff. And in this case, we can set the allow gravity flag. We can set that to false. So in this case, my ground, for example, doesn't have gravity anymore. Why do things don't collide? They should hit each other. Well, that's only if we define so in update, and we're not doing that in this lesson. So for now, nothing touches each other. They're all physically simulated, but imagine that they're in like parallel universes, so they don't touch each other. So that's for the ground. We also want to do it for the platform. We want to disable gravity. So now only our player has gravity. The other thing that you want to do for those two things is to make them immovable. Example, if you punch somebody on the face, you'll see that the face of the person will move towards the direction of your punch. Don't try that at home, but that's what happens. And in here, if we make things collide, the same thing will happen. So the player will fall and it will hit the platform, and then the platform will also start moving down because you gave it a momentum. So we have to make them so that they cannot be moved. Unless, of course, you want to have platforms where once you jump on it, they start to fall down, which you find in some games. So we'll do unmovable equals true. So that will make them so that you cannot step on them and move them downwards once we implement collision. So platform immovable true. Okay, so we have now we've started the physics engine. You need to do that before you can start using it, and then we enabled individual sprites to be part of the physics simulation. We've learned how to enable gravity on a global level and how to disable it for some of the sprites, the ones that we don't want to fall down or up, or whichever direction your gravity is pointing on. And then if we want to avoid having elements when they collide to each other, to have them both, to have the element that was hit moving, which would happen in say if you stand on something, if you move something, if you push something, that other thing will move. So if you want to make it so that it doesn't move, you have to make it unmovable with true.